All right, guys, we're going to go ahead and do our notes on 3.6a. If you haven't done video notes with me before, the way it works is I'll go ahead and walk you through the notes, just like we do kind of in class, do a couple of them together. Then I'm going to have you try some on your own. And what I'll do is I'll tell you, all right, go ahead and try yours on your own, pause the video. Actually, go ahead and pause the video and try it on your own. Nothing's stopping you from just watching it straight and through and copying down the answers, but I want you to actually try to do it. So when I say pause it, actually try the work, and then kind of see if we did it right or not. If you need to erase, go back again, play the video again, whatever, but go through and try those things. Okay, so we're going to use a couple ideas first. The first thing is to find the distance between a line and then a point that's not on a line. So if we're trying to find the distance of line AB and point C, okay, what it's going to be is it's going to be the length of the segment that is going to be perpendicular to that line. So that this guy right here, we're going to find that length. Um, and so we could do that because of this postulate 3.6 here, that if we have a point and a line, there's only one line that's going to be perpendicular. So we're going to find that perpendicular line, and then we're going to find the distance from the point to here. Okay, so what we're going to do is first one, we're going to find the distance between the line y equals x minus 2 and the point 2, 4. Okay, so the first thing we want to do is we find the slope of the original line. Well, the original line, the slope is right there. And so it's negative 1 over 1. Okay, so now the second thing we got to do is find the slope of a perpendicular line. We need to find its opposite reciprocal. The opposite reciprocal is positive 1 over 1. Okay, so what we need to do then is we need to graph the original line. So start at negative 2. We go down 1 over, down over, down over, down over, down over, over, back, 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 back. So that's our original line. Okay. Then we're going to plot the point 2, 4, 1, 2, 1, 2, 3, 4. Okay, and we're going to find the perpendicular guy to our original line, which means we're going to use this slope right here. So we're going to go up 1 over 1, and then we're going to go down, back, down, back, down, back, down, back. Okay, and we find out where they intersect. Well, they intersect right there at that point. Okay, so the intersection point is negative 2 comma 0. So what we're going to do now is we're going to find the distance from this guy, that point P, to this guy, that intersection point. So we're trying to find the distance between the points negative 2, 0, and then 2 comma 4. Okay, and we use our distance formula. We're going to go square roots. We're going to say 2 plus 2 squared plus 4 minus 0 squared. So that's the square root of 4 squared plus 4 squared. So that's the square root of 16 plus 16, which is the square root of 32. You put that in your calculator because we're finding the actual square root. And the square root of 32 is 5.7. So the distance from the line y equals x minus 2 to the point 2 comma 4 is 5.7. Okay, really, I'm looking at this guy right here. I'm looking at that square root of 32. All right, let's try another one together. Okay, we want to find the distance between 2x plus 1 and then the point 5 comma 1. So 2x plus 1, we start at plus 1, we go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, down, back, down, back, down, back, down, back, down, back. So here's the line. Okay. Then we're going to go ahead and plot the point 5 comma 1. 1, 2, 3, 4, 5 comma 1. So we're trying to find the distance from that line to that point. First thing we use, we write down where our slope is, and our slope is 2 over 1. So the perpendicular slope is its opposite reciprocal, so it's negative 1 over 2. So from our point, we go up 1, back 2, up 1, back 2. Now, the problem becomes find the distance between those 2 points. So that intersection point is 1 comma So we're going to find the distance between 1, 3 and 5, 1. So square roots, we're going to go 5 minus 1 squared plus 1 minus 3 squared. So that's 4 squared plus 2 squared. That's the square root of 16 plus 4. So that's the square root of 20. Put that in your calculator or as theorem, and that is 4.5. Okay, so the distance from our point to that line is about 4.5. Okay, so now I want you to go to the back. I want you to try that one. Okay, so hit pause. Once you hit pause, and you're going to go ahead and try it. See if you got it right. All right, let's see if we got this one right now. Go ahead and graph negative 3x plus 4. So 1, 2, 3, 4. We're going to go down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. I know it's really annoying. Get over it. And then up 3 and backwards. Okay, so there's our line. And our point is negative 3, 3. 1, 2, 3, 1, 2, 3. So right there. We got to find the distance from that point to that line. The slope we had was negative 3 over 1. So the slope perpendicular to that is 1 over 3. So we're going to go up 1 over 3. And we want to find that distance right there. So from the point negative 3, 3 to the point 1, 2, 0, 4. Do the distance formula. We got the square root. We got 0 plus 3 squared plus 4 minus 3 squared. So that's the square root of 3 squared, 1 squared. That's the square root of 9 plus 1. That's the square root of 10, which is approximately 3.16. What you said, 3.2. So the distance from those two, from that point to that line, is 3.16. Okay, we're going to try another one here. Now, between the line x equals negative 3 and that point, so x equals negative 3, that is a flux. It's a vertical line right here, going straight up and down. Okay, so find the distance between that point, or that line, and then the point 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Okay, so the slope of the line is undefined. So the perpendicular slope would be 0. So we're going to draw a HOI in there. Okay. Well, now that point of the intersection is this guy right here. That is, what is it? Negative 3, comma negative 6. And then 4, negative 6. We find that distance. We're going to go, the distance is 4 plus 3 squared plus negative 6 plus 6 squared. So that's the square root of 7 squared plus 0 squared. That's the square root of 49, which is just 7. Gosh, I really wish there was an easier way to do that. And there is. We can just count 1, 2, 3, 4, 5, 6, 7. Because it's a vertical line and a horizontal line, we can go straight across. We just count that it's 7 away. Okay, try the next one. Hit pause, see what you can do. All right, we're going to go y equals 6. That's a HOI. 1, 2, 3, 4, 5, 6. We're going to go straight across. We're going to find the distance to negative 3, 8. So 1, 2, 3, 8. So we're going to find that distance right there. So we know the slope of the original guy was 0, so the new guy is fine. We have the flux coming down. Okay. Hopefully you didn't actually do the distance formula because we know that is just 1, 2 away. And that guy is 2. And that's your answer. Okay. That's all you got. Take your notes up to show the sub that you got them completed. Get your homework. I think there's 8 problems. You have the rest of the period to work on them. I'll get the quizzes for you when you get back on Monday. Hope you guys have a great weekend, and I'll see you Monday. All right, later. Bye.